All right, let's finish this up. So on page 201, we're on page 201. Page 201, we are talking about rational zeros theorem. So let's go look at the theorem itself. In the blue box, it says, suppose f is a polynomial function of degree n is greater than or equal to 1 of the form following. With every coefficient an integer, okay, every coefficient an integer and a not equal to 0, if x is equal to p over q is a rational zero of f, where p and q have no common integer factors other than plus or minus 1, then p is an integer factor of the constant coefficient a naught, and q is an integer factor of the leading coefficient of a n. Okay, so that's a whole mouthful there, right? That's a whole mouthful, okay? What they're saying that if you have x is equal to p over q, what they're saying is that this is basically, what is this? This is, it's gonna be equal to qx equal to p, which means that qx minus p is equal to 0, right? So in other words, this is a factor. If this is a factor, what they're saying is that this guy, p, is a multiple, or somehow it's associated with the constant, whereas this guy is associated with the leading coefficient. Okay? So, all right? So what it's saying is that if I have a polynomial function that looks like, let's say 2x minus 4, okay? Then if these are all integers, right? All these are all integers, okay? That means that if x is equal to p over q, which means that this is what it's going to look like. In other words, if I have, this is a common multiple of 4, so it's going to be plus or minus 1, plus or minus 2, plus or minus 4, okay? On the top and on the bottom, you're going to have plus or minus 1, plus or minus 3, okay? So the 1 obviously doesn't do anything for you, right? Because this divided by 1 is just the number, okay? So in other words, the possible answers or factors to this is going to be plus or minus 1, plus or minus 2, plus or minus 4, which was the division when you divide it by 1, right? And then you're going to have plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3. Okay, and the 3 comes from the leading coefficient. Okay, the 1, 2, and 4 comes from the factors of 4, right? 4, right? 4, okay, right? So this is what you have. 1, 2, 3, 4, 5, 6. So I have 12 of them. I have 12 possible ones that I can go ahead and try out. Okay, so I'm going to give you a hint here that it's not in the book. Or is it in the book? I don't even know if it's in the book or not. Okay, look at this guy right here. If you look at this guy, and I added all the coefficients, if I just straight add all the coefficients, okay? If I straight add all the coefficients, I have 3 plus 3 minus 2 minus 4, okay? That means that automatically, in that case, if I add them, they all add to 0, correct? If they all add to 0, this is basically the same thing as me saying, if this is f of x, me saying that f of 1 is equal to 0. And why is that so? Because when I put f of 1 in here, when x equal to 1, all I have left over are the coefficients, right? Can you see that? Because f of 1, if I put f of 1 in here, I'm going to have 3 plus 3 minus 2 minus 4. Okay? So, in other words, if I add all the coefficients together and f equals to 0, that means that this guy here is factorable, or one of the zeros is this guy right here, x minus 1. Now, so let's see if we can verify this. We can verify this by doing what? We can do the synthetic division, right? And see if it works. So let's see if I do the synthetic division, see what happens. 1, I'm going to have 3, 3, and then I have 0. I have a placeholder for x squared here. Minus 2 minus 4. 3, 3, add together is 6. I get 6, add together 6, multiply out, add together. So I'm going to add together 4, 1, 4. There you go. It works. Right? Okay. Right. So that's one of the things that you want to look for, okay, to get a quick answer. Okay. All right. So that's that. So let's see if we can do example number 4. Let's see if we can do example number 4. Example number 4. Find the rational zeros of x cubed minus 3x squared plus 1. Okay? So, what are the possible zeros that I can have here using synthetic division? All right? It'll be plus or minus 1, right? Basically plus or minus 1, right? Okay. Because this guy's here's going to be 1, so it doesn't really matter, right? So plus or minus 1. So if I do f of 1, I get what? F of 1 is equal to 1 minus 3 plus 1. This is not 0. F of negative 1 is negative 1 minus 3 plus 1. Again, not 0. So neither one of them work, okay? So basically at this point, there is nothing rational. There are no rational zeros, right? I can find other zeros and I can go ahead and just graph it. I can trace it and find it, but they're not going to be something that's simple or as a rational number. Rational number meaning it is, you can put it in P over Q form, okay? Okay, so that's example number 4. Let's do example number 5. Find the rational zeros of, so example number 5, I have f of x is equal to 3x cubed plus 4x squared minus 5x minus 2. So what are my possible zeros here that I'm going to have is, so I'm setting this equal to 0. I'm trying to find the zeros. So it'll be plus or minus 1, plus or minus 2, right? But then I have the 3 up here. So I'm also going to have plus or minus 1 over 3, plus or minus 2 over 3. Okay, so I have 8 of them. I can try these in. I can put these in. So oftentimes you will find that as you're doing synthetic division, it becomes kind of tedious, right? Because there really is no good way, except for the one that I told you, the 1, okay? Other than that one, there is no other way. You just have to just try and see if they work, okay? So now on this one, as a matter of fact, on this one, what do we have? I have 3 plus 4 minus 5 minus 2. Oh, that's 0. So I know that 1 is an answer. So I know that 1 is an answer. So let's use that and do the synthetic division. So it comes down to be 3. 1 times 3 is 3. Add together is 7. 7 minus, so if I add them together, I get 2. 1 times 2 is 2, is 0. Okay, so this is basically x minus 1. Then I have what's left over? I have 3. This is a quotient, 3x squared plus 7x plus 2 is equal to 0. Okay? So from here, it's almost easier to do what? To do factoring here, right? So if I factor this out, what do I get? I get 3, 1, 2, 1, right? It's 3x, x. So this would be 6. This would be 1. Add together would be 7. So we're good to go. So this is going to be x minus 1, 3x plus 1, x plus 2 is equal to 0. Okay, or, I mean, I could have continued on with a synthetic division, right? So what do I have? I have x equal to 1 minus 1/3 minus 2, right? Okay, so let's see if in fact I can continue to do the, so I had 3x cubed, 4 minus 5 minus 2. And I had already did the 1, right? Because I knew that was going to work. So I did 3, 3, 7. 1 times 7 is 7. 2, so I have 2 here. 1 times 2 is equal to 0. Now the next ones are negative 1/3 or negative 2. So let's say I tried negative 1/3, right? Let's see if I can do that. Negative 1/3. So I come down 3. Negative 1/3 times 3 is negative 1. Add these together, I get 6. 6 times negative 1/3 is negative 2. 0, there you go. What do I have left over? I have 3x plus 6 left over. So what makes this 0? Negative 2, right? And that's the third one right here. So I have all 3 of them. Okay? So that's how you would do that, blah, blah, blah. And then there's a upper and lower bounds. Okay, I'm going to tell you right off the bat that this is something that is kind of esoteric almost. Really don't know how often you will see it, but it's in the book, so we'll go over it. Okay. Let's read the blue box together. Okay, let's carefully read this. Let f be a polynomial function of degree n is greater than or equal to 1 with a positive leading coefficient. Okay, a positive leading coefficient. Suppose f of x is divided by x minus k using synthetic division. If k is greater than 0, and every number on the last line is non-negative. In other words, they're either zeros or positives. Okay, then k is an upper bound for the real zeros. So the highest 0 is going to be that, okay? Because it's the upper bound. If k is less than or equal to 0 and the numbers in the last line are alternately non-negative and non-positive, then k is a lower bound for the real zeros of f. Okay? So this is a mouthful. Let's go ahead and actually just go ahead and do it out. Let's go ahead and do example number 6 and see what they actually mean here. Example number 6 says, prove that all the real zeros that is must lie in the interval -2 and 5. So in other words, -2 is the lower bound, 5 would be the upper bound. So let's go with the upper bound first, okay? Let's do the upper bound first. So if I had 5, okay, and my function was what? 2, -7, -8, 14, and 8. So I get 2, 5 times 2 is 10, add together is 3, 15, add together is 7, I get 35, add together I get 49. 49 times 5 is 245, add together is 243. Okay, so every number on this line is non-negative, right? Non-negative. It's non-negative. Okay, so this must be an upper bound. It's an upper bound, okay? All right, and then on the other one, I have what? -2. So let's try -2 and see how that works. -2, 2 comes down, -4, -11, 22 add together is 14, -28 add together is -14, -14 times that is 28, so it's going to be 36. Okay, can you see how they're alternating? Positive, negative, positive, negative, positive. Okay, what was the word that they used? They are alternately non-negative and non-positive. So this must be a lower bound. Okay, that's why this is a lower bound. Okay. So example number 7. Let's do example number 7, and that'll be our last one. Example number 7 says, find all the real zeros of f of x is equal to 2x to the 4th, -7x cubed, minus 8x squared, plus 14x plus 8. Okay, so what do I have here? I have the possible zeros are plus or minus 1, plus or minus 2, plus or minus 4 here, right? From the 8, right? 1, 2, and 4. Okay, then I have to divide it by 2, right? So if I divide this guy by 2, I just end up with this guy. If I divide this guy by 2, I just end up with this guy. But I do have plus or minus 1/2. So I have 1, 2, 3, 4. I have 8 possibilities here. 8 possibilities. Okay, let's try the 1, see if that works. 2 minus 7, that's minus 5, minus 13, plus 1, plus 9. So 1 doesn't work, okay? So we can actually just cross off 1 already, right? And so you can try other ones, but I'm gonna cheat. And the book says 4 works. Woo-hoo-hoo. So 4, 2, -7, -8, 14, 8. 2 times 4 is 8. 1, 4 times 1 is 4. -4, -16, -2, -8. So yes, it works, okay? So I know that 4 is, and so what do I have left here? I have 2x cubed plus x squared minus 4x minus 2, okay? So I know this guy works, so now what do I have left? Let's try -1/2. This seems to be also a good answer. 2, so I get -1, 0, 0, -4, plus 2 is equal to 0. Okay, so what do I have here so far? I know that's divisible by this. So this guy here is x minus 4. If I divide it by that, I'm going to have this guy left over, correct? 2x cubed plus x squared minus 4x minus 2, right? But this guy here is when I take it by this, I get this guy. Okay, so what is this? This is basically x plus, it's 2x plus 1, right? I'm setting this equal to 0, correct? To get the -1/2, right? So I move the 1 over to be -1, I divide it by 2, and I get that. So this is basically the same as x minus 4, But here we go. I'm going to go ahead and say x plus 1/2, right? Because that's what this guy is. I'm going to have this guy left over. 2x squared minus 4. Okay, now something here happens when I do the 1/2 or something like that. What actually happens is I get a situation where I have a 1/2 here, which is kind of odd, but I also end up with this guy, which means that I can take the 2 out here, right? If I take the 2 out, this becomes x squared minus 2 times 2. And I can now take this 2 and multiply this guy into here, x minus 4, 2x plus 1, x squared minus 2. So I end up with this somehow in the end, right? Which is, right? Okay, but the 2 came out from here to, I can go ahead and put it back in here, right? So I get 2x plus 1, right? And what I left over, I have x squared minus here. So my answers are what? X equals to 4 from this guy. From this guy, I get negative 1/2. And then from this guy, I get plus or minus root 2, right? Because over here, if I set that equal to 0, what do I have? I have x squared minus 2 is equal to 0. I move the 2 over, I get x squared is equal to 2, right? So x is going to be equal to plus or minus root 2. And that's where this guy comes from. Okay? Okay, and I'm not even going to go over example number 8. I'll leave that with you guys. The only good thing about number 8 is that you have a situation where the coefficients add to 0, so you do get x minus 1 right off the bat. But other than that, you're still going to have to struggle through. Okay? All right, we're good. I'll stop right here.